Hi, and welcome to the COVID-19 Data Analysis Case Study Project, where we take a look at the worldwide COVID dataset, and we do some exploratory data analysis, some statistical analysis, and some pretty cool visualizations. So stay tuned, and we move on to the first lesson in this case study. Thank you. Hi. Okay, so what we're going to do, we're going to open the COVID-19 Data Analytics IPython notebook file in the case studies folder. So I already have it opened here, but if you want to do it on your own, it's just open with Google Colab. So right click, open with Google Colab, or just double click on it and you can go open with Google Collaboratory. So now let's move into the notebook. So we're going to do quite a few different things here, and what we're going to do, I'm going to scroll through this notebook very quickly. We're going to do a lot of different types of visualizations, analysis, comparisons, graphs, timelines, all these different things with COVID. You can see some of the cool stuff we're going to do here. I know it's going to be a bit hard to watch on your screen as I'm scrolling through pretty fast. The last thing I'm going to do is actually a COVID bar chart race. So you can't actually see the animation here, but it's going to be a pretty cool timeline animation to show you from basically from early January, the COVID cases around the world, which countries had it, all the way to the present day right now. So let's move back up to the top. Whoops, just got stuck on one of the maps there. Alright, so the first thing we're talking about is, let's see where we're getting our data from. So our data comes from Our World in Data here, this website, and it's this is the direct link to the data set here. And this data set is updated every day, probably multiple times a day as data comes in. And it's pretty cool because no matter when you run this line right here, because it's pulling from the URL here, this data you pull into your Colab notebook is always up to date. So let's check it out. So let's load our data here. It's taking a bit of a while, but it should be done shortly. Any minute now, I hope. Okay, so that's done. So if for some reason your Google Colab takes a bit of a while to load this data set, you can always do a quick refresh on the page. Sometimes it doesn't connect well, but it should load fine. So this is a pretty big data set actually. I don't actually show you how big it is here, but let's just insert this code block here and we can take a quick look. DF, and you can actually see has 52,000 rows of data and 41 columns. Basically, it's every country in the world. It's a bunch of different fields they're collecting here, and let's go through that. So I've filtered it on my home country, Trinidad and Tobago. So to do a filter, what you have to do, remember, it's DF, open square brackets, DF, the field you want to actually filter on. So we're looking at the location field, and Trinidad and Tobago, you have to use double equals like a boolean, equal Trinidad and Tobago, and that's how you get this table coming up below. And let's see, it ends basically at the 23rd of October, which is today, and Trinidad and Tobago is up at 5,446 cases, an increase in about 50 something from the previous day. And you can see, well, 54 actually, has new cases nicely put here. You can see the new cases smoothed. That is a rolling average, I believe. Haven't actually looked into it to see, but it looks like a rolling average to me. Total deaths, so we're at 103. New deaths every day popping up. New deaths smoothed, again a rolling average. Total cases per million, this is how much cases per million people in the population, just to standardize it and normalize it across countries. New cases per million as well. New cases smoothed, total deaths, new deaths per million. All of these things, again, another new deaths per million moving average. Smoothed, sorry, this is moving average, yes. A lot of these fields you can see in some nans here. That's because the data isn't available, like total tests, new tests. Even though I know it's available for my country, it's not being pulled into this data set for some reason. But that's okay. We're not going to do too many things on this. It's not going to be a deep dive analysis into all the COVID data, because that's what a lot of like data scientists and epidemiologists are doing. We're going to do a high-level view, high-level data analysis, uncover some cool findings, some cool animations, some cool plots, get a good deep understanding of the COVID data as well. So you can see data, it keeps on going. There's a lot of different columns here. There's population density, population stringency index. This is basically how much or how the level of lockdowns that are taking place in the country. You can see earlier, because there's a gap here, this isn't from I think January or actually March. you can see stringency index was quite lax, and now it's quite strict. And keep going, how many over 70, that's a factor in terms of mortality rates, I'm sure. Extreme poverty, lots of diabetic information. This is actually pretty cool. So there's a lot of information you can use here to visualize and process. I'm not going to do everything, it's a lot to do, but it's actually a very good homework lesson for you to do. I'd love to see some notebooks you guys do with this data. So now let's just quickly get a summary of the missing data in this data frame. And what we're going to do, we're going to do something quite a little fancy here, using a list comprehension to check it. This list is going to store all the nans here, and then we just put it back into the data frame to get the percentage of nans that are here, missing. So, and we have the column name here for the columns that are missing as well. So what we do here, we just get the columns. If it is not NA, we get the average in columns, find it as a percentage, and use this list comprehension for C here for every column in the notebook. We're going to do it here. Okay, so quickly let's do this. And you can see how the percentage of missing information in each column here. Remember, these are the columns in the data set here. So not every country is going to have the data you want in the data frame, unfortunately. Some countries are going to be zero nans because they have all their data open, publicly available. Some countries, like my country, is a bit closed on data. They don't like to share their stuff. Venezuela is even worse. Countries like Syria, North Korea, they want to hide everything. But then you have a lot of the Western European countries, New Zealand as well, very open in sharing their data, because being open with data is a very good thing. It's never good to be closed. When you're closed with data, it means you're generally hiding something. Okay, so we can just take a look at the countries that are our data set. I like to do little things like this just to get a feel of what's in the data set. So you can see we have, this is all the unique countries in the data set, and I just want to get an idea of how much countries it is. So you use length in the unique list here just to get a length of this list, and it's 213 countries. However, you can see the last two, world and international, those aren't really countries. The international was logging, I think it was the people stranded on cruise ships in international waters, and world is just a sum of everyone per se. So now let's take a look at the COVID world analysis, the most recent info, so you can get an idea of what's happening. So let's move on to the next lesson. Alright, so moving on, what we're going to do now, we're going to do a world analysis summary of the most recent COVID info. So that's like yesterday's data. We're just going to quickly take that data and summarize it. So firstly, how do we, well, before we do move ahead, we need to actually delete, like I said, the world data from here, because this is a sum of all the data. Now, technically, you can just filter on the world data right now if you wanted and get a summary, but that's like cheating in a way, because not all data sets will have a summary at the bottom. So let's see how you do this. So let's firstly delete the world summary figures, and by doing that, we just do df drop, and we just identify the df here. We filter on this location here, so we put df square brackets df.location equal to world. That's what we're going to drop, that index, and then we're just do an in place type operation, which means that we don't have to put df equal to this. In place means it actually changes the df in this line as well, and we delete it. So that's cool. And then what we do, since we have the date data here, we're just basically going to filter on the max date only, and then we set that index just because we just want it in a nice, neat data frame like this with not multiple rows. I mean multiple hierarchies of indexes. And so that's basically it. So let's do this, and you can see we get yesterday's data, which is the 23rd of October, and we get it like in every country in the world. So you can actually see the tail. Remember, .head is the first 5, .tail is the last 5. You can just quickly check out what the bottom country is alphabetically. Yemen, I'm not sure why Yemen is the best and South Africa is here. Probably sorting on something else besides country name here. But that's beside the point, because it does seem alphabetical up here, but South Africa is somewhere here. Probably it is on ISO code, but not, yeah, maybe ISO code. Cool. Okay, anyway, that's besides the point. Just me thinking aloud, trying to figure out how this thing was sorted. And we can see this is the data for these countries at the bottom here. So now let's go ahead and make our summary table. So I'm not going to show you what it looks like yet. What I'm going to do is I'm going to do a group by here. What I'm doing this group by for is a group by date. So we're just going to get everything by that date. We're just going to get the sum of the total cases, new cases, total deaths. Why did I choose these 3 columns for? Because total cases give us the most recent figure up to that date, and then new cases give us basically the same thing, the new cases for that day up to that date, and total deaths. Okay, now right, so we pick total cases, gives us the most recent up-to-date figure of total cases. New cases gives us all the new cases reported in the last day, and total deaths, we can actually put this all on one line because it doesn't need to be on 2 lines in my opinion. And total deaths will give us the total deaths up to that point in time. So, and we just get the sum of these columns here. All right. Speaking of which, we're doing this DF on the DF most recent. That's the one where we just got the max date information for, just in case you're wondering, not the DF overall. And we're calling this DF world. And then what we do, we just create some column labels here because we're going to use this in the plotting, in the figure plotting we're going to do. So actually you see our results here. But now let's just plot it again to get it more up to date. So you can see 40 million cases worldwide, 433,000 new cases up to the point in this data, and we have a total of 108,000 deaths. That's quite, I mean, sorry, a million and 87,000 deaths. Okay, that's quite a lot. So now let's take a look at how we were to add in a column, because in case you're wondering, total new cases, or basically total new cases, total new deaths is missing. So how do we add that in? So let's look for the column we're looking for. So new cases exist in the column in this data set here. Maybe new deaths, and new deaths does exist. So let's take a look and put new deaths in here. And we don't have to add it in as well here. But let's just give it standardized nice, neater name. And we're also going to have to put a comma here and add it in down here. We'll actually add this one in down here. So let's use double apostrophe for consistency. And there's 2 here, which we don't need. And there we go. So let's do this. And you can see new deaths, 6,000 new deaths. So that is not good. 6,000 people died yesterday from COVID. So you can see how we quickly create this nice summary table here. If you wanted to make presentations or have a bunch of like nicely presented notebooks, you can use this type of table layout here with Plotly. Okay, remember I'm going to scroll pretty fast. We're using importing plotly.graphObjects as Go. Okay, GraphObjects is a sub function or sub module inside of Plotly that allows you to do these cool things, and Express allows you to do a lot of cool plots as well. So now let's move on. We're going to move on to the next section where we take a look at world COVID growth over time. Okay, stay tuned. Okay, so now let's take a look at the COVID-19 growth over time across the world. So what we're doing here, we're going to produce this little sheet here, and what we're doing, the summary sheet shows you basically grouped by every day of the year, total cases, total new cases, and total deaths. All right, so let's just run this code here. Now you should be familiar with group bys right now. Grouping by date, and we're just basically getting the sum of total cases, total new cases, and total deaths occurring every day. Okay, and then we just sort it ascending equal true, and we reset the index, drop equal true, reset the index here. This is a pretty long chain command, as you would know by now. We should be familiar with chained commands in pandas using group bys right now. It's not hard. You'll get used to it if you're not accustomed. Okay. So now let's take a look at confirmed cases starting from day 0. So this is our nice summary table, and we have this for every day of the year up till our present day. You can see it right here. So this is cool. 4 million cases, 432,000. Sorry, it says 40 million cases, I should say. There's no comma to help me with the decimals. Big numbers confuse me sometimes. Yeah, I'm sure it happens to you too. This is 433,000 new cases and 1 million deaths here. Now, you may notice, and I've noticed this as well, that this number in the 23rd here is less than the 22nd. So why is that actually? Well, unfortunately, Well, unfortunately, our world in data, their data set isn't updated correctly for the last day. Maybe it's missing information, but to me that doesn't make sense, because there's no way the total cases can be less than the total sum of cases can be less than the previous day. So it appears that something is not being calculated in the latest day row. So unfortunately, what we can do to solve that problem is just to delete that row. So let's quickly do that. So to do so, we can put df over time, open brackets, df over time again, square brackets, df. This is let this be a lesson into why you don't use long data frame names, because when you have to chain commands like this over and over, it gets quite tedious, and it becomes very lengthy to have these long chained commands. So maybe something short next time, from advice to myself in future. Anyway, so we can do dat is equal to the date 2020-10-23 dot index, comma, and we can do an in place operation so that we don't have to let it equal to the data frame name again, just to save line space, and df over time just to make sure we do it correctly. Data frame is not callable. Where did I make this error? Let's check it out. Okay, silly me, forgot to put the dot drop in front of this here, so that should work now. There we go. So we've deleted the last row, which is the 23rd of October, mainly because that row had some incorrect data, unfortunately. All right, so moving forward, let's just check. Yeah, everything seems to be all right. Moving forward now, let's do the confirmed COVID cases starting from day 0. So day 0 is interesting. Day 0 will be counted as the first day within the data frame, which is the 31st of December 2019. And what we're going to do, we're going to create a plot like this. This plot basically shows how COVID grows basically from day 0 to where we're at right now. This was a dip from the 23rd of October before we deleted. So let's just run this now and just get a nice cleaner graph. There we go. So we can see we have this nice looking line graph here. So we can take a look at the figure plotting tool and how we did it. Basically, we used go.figure, so we have .fig. So we add a trace. A trace is basically a line that you can see here. We have used go.scatter inside of here just to get the data points aligned. So we use df over time index. Now, if you wanted to change this to date, it should work, and you'll actually have it with dates here, which is, to me, it's actually nicer to use dates. You can do dates or day 0, up to you. Just put it back at day 0 because I call it day 0 here. And over time cases, you can just plot total cases here. This can be changed to total deaths if you wanted, just to change up the graph. Just normal XY axis labels here, and that's how you get this nice looking graph. Now, oh yeah, so I actually did it with a date right here below, so you can see it, and I just changed how the graph looks using a bar instead of a scatter. What's wrong here? Date over time. Okay, that's because I renamed the data frame data over time and changed it to df over time, which is quite silly. I'm guessing this boy wanted to make this variable name shorter, as I said before. So there we go. Here's a nice bar graph, basically illustrating exactly the same thing above. Instead of a line, we have bars. So now, and then we have a time axis instead of the 0-day axis. So now let's move on to a couple more plots. Let's do the COVID deaths over time as well. So you can see this graph looks with a black background and a red line, and how we change those things is right here in the update layout. So we just put plotly dark as a template, and we just use the color red for the marker line. You can look up to see what other plotly configurations they are. They are quite a bit. This one is one of my favorites, but you can have your own tastes and preferences as well. Now we're going to go for COVID new cases over time. This is an interesting graph. I can show you basically how actually, let's change this to date axis. I don't like using the index axis sometimes. So there we go. So you can see how basically this is what happened in Wuhan initially, and Italy, I believe, or Iran. No one was taking it that seriously back then actually this is Wuhan, I remember. Then Iran got it, then Spain, Italy, the US started to get it slowly. Then it seemed to just explode all over the world, and then it kind of stabilized over the summer. And then as things began to reopen, bam, this is where we are right now. Definitely not out of this COVID situation by any means. However, what's good is that let's actually create a new graph here. So let's copy this code here, create a new cell below, and now let's put new cases. Let's put new deaths. So some good COVID news. You can see, oh, it's probably a new death. Actually, let's get the name of that figure. Actually, I don't believe we have new deaths in this data frame, so let's add it in all the way back up here. So at the beginning of part 3 we didn't have new deaths, so let's add in new deaths here, and there we go. And let's just drop the date as well. So now let's go back to the graph we wanted to use. I know I'm going a bit fast, so what you guys should do is just either watch me pause the video and try to replicate this on your own notebooks. You'll have these finished notebooks at the end of the lesson, so you don't actually have to copy and paste this. This is what I'm doing. But in case you wanted to do it on your own, which I always encourage, just pause the video and copy and paste, or do what you need to do on your own. You would learn a lot better by toying with these things alone. And these data sets, they have so much to play with and to manipulate, so there are always things you can do. So new deaths should be here now. Let's change this to red. Red represents death, in my opinion. So you can see what's good is that we're over the scary situation we were in mid-April when deaths were skyrocketing across the world. Even though it's still rather high many times, it is sort of stabilizing as of right now. Although I do expect it to have a spike after the surge comes through. You'd probably go back up to close to maybe 8-9K, but we hope not. So let's see what happens. So now let's look at the confirmed cases in each country in the next section. So stay tuned. So now let's move on to getting the confirmed cases in each country, so we can take a look at it at a per country level. So this is relatively simple, so I'm actually going to step through this slowly for you guys. So let's just make this, we're going to do this line by line, okay? So where am I? All right, put a head here. So what we're going to do, we're going to do a group by on location, and we're going to group by, get a sum of new cases and new dates here. This will give us a sum of total cases in the country overall at this point in time, as well as new deaths. And we'll reset the index and sort the values of new cases in ascending order, and then reset the index again with drop equal true. And therefore just get a nice little data frame here that shows us all of these things here. All right, so we get a nice clean data frame here that gives us how many cases each country has, sorting by the highest first. So let's see the top 10. Top 10 would give us this figure here, which is interesting. You can see it's a lot of South American countries here: Colombia, Peru, Mexico, Brazil, Argentina, followed by the similarly Southern European countries of Spain and France. And then we have US and India and Russia coming up in the top 3 or 4 again. So that's quite interesting. And if you wanted to see the reverse tail, the bottom countries, these are all going to be very tiny countries or countries with low populations. And you can see these as well. So it's interesting. Not sure how come Hong Kong never had a case. That is odd. Maybe it's logged under China. Maybe that's wrong to say, but I don't know. But it's just odd. And now let's just leave it as head top 10 actually. So whoops. All right. So now we're going to just rename these columns here, I should say. So we get nicer columns as well, nicer column names. And what we're going to do, we're just going to change the types data as well to get rid of these decimal points here. So obviously country is a string. Probably didn't need to do that, but we just still did it here. Total cases are int and digital that's int. So we get this nice little cleaned up data frame here, which I like to see. So there we go. So now let's put this into a bar chart so we can visualize it for each country. So again, we're using the go from Plotly. So go.figure, We use a go bar. We specify what x-axis is. Its x-axis is going to be the total the cases. Y-axis is going to be the countries. You can see them actually lined up here. We're going to put it on a horizontal axis as well. So that's why actually I paused a bit here when I was reading this out, because I'm like, this should be the reverse, but actually no, it's correct. And then here we go, just the normal titles and axis labels. And here we go. So we can see the confirmed cases here are on the x-axis here, and you can see the countries on the y-axis. Now Plotly does something that's quite nice. It cleans up the graph for you here, so you don't have all the words overlaid on top of each other like in previous libraries. That would look quite messy. So unfortunately we can't specify what countries you want to see just yet, but luckily they picked out some random countries for us in the list, and you can, if you wanted to see the actual country names, you can just hover over here and you see all the countries popping up. Now it's going to be a bit crazy to find a country you want to find like this, but it's just a cool way to visualize all of the countries in the world in one simple bar chart and see how they rank against each other here. So now let's do the same for debts. So it's similar, exact same code as above. We're just going to change some of the color schemes as well, and the title debts as the label, as the column label we're looking at. And there we go. The difference with this is that this data set was sorted by total cases. So if you wanted to sort it by total debts afterward, just make this graph look a bit neater and cleaner, you can do that as well as a nice little homework lesson for you guys. Okay, so now let's go on to the 5th chapter, where we take a look at mapping COVID across the world. So stay tuned. Okay, so back to our COVID project, and now we're going to look at mapping COVID across the world. So we're going to produce some very cool world map visualizations to show how COVID has affected every country in the world. And this visualization is very useful if you want to just get like a quick view, a snapshot of what's going on across the world. So let's take a look at how we do this. So the package we're going to use is from Plotly PX, and it's called a choropleth graph. It's a bit hard to say sometimes. And we're going to use the DF per country dataset. That is what we used previously up here. And now let's scroll back down. And the locations, we're going to have to pinpoint this to tell it that we're looking at the country locations here. Locations need to be country, and as we're doing a world map. And luckily, the country names in the COVID dataset line up and match perfectly with the country names in the Plotly's PX choropleth package, because sometimes some countries, it's not case sensitive, so you can use lowercase Uganda or Senegal or Cameroon and it's fine. However, sometimes, like for some countries, instead of having South Africa, they will have RSA or Republic of South Africa, or instead of the US of the United States, you'll have USA or the Czech Republic. And I believe when you have names like that, it kind of messes up with the choropleth package. Luckily, that's not the case here. We don't have to do any country lookup type dictionary thing to get the correct names. Color is going to be, the color of the countries are going to change with total cases. Countries with a lot of cases are going to be in a different color, and countries with little cases are going to be in a different color. And location mode, which like I said before, is country names we're using. Then we're going to do the hover name. When you hover over a country, you're going to get that name as well, and we just set the template to dark. We're going to use the orange to red sequential color, continuous color scale. And well, anyway, enough about that. Let's just plot this now. And you can see we have a nice map right here. And you can see a lot of the countries here are basically kind of white and cream, which means that they don't have that many cases. And in the case with Africa, that's because I don't think the testing is extensive as it is in some of the other countries. So the scales are a bit warped, like US and India dominate the red colors, and the other countries aren't represented properly here. So something is wrong with this diagram. What we need to do is adjust for population size, because let's take a look at the data frame again to remind you of this, that luckily we have total cases per million, I believe, right here in this column here. I don't know why it's none. Well, that's because in this beginning here, Afghanistan didn't have any cases here. So anyway, but we'll have it later on. So now instead of doing what we did previously in the group bys above, anyway, you remember, sorry, I didn't mean to distract you with scrolling. we're just doing a group by location, country location, new cases per million, new deaths per million, and we're just doing a sum and all of this and resetting the index. I guess you guys would remember that. And we're calling this data frame df country per million. So let's just run this, and we get this nice new adjusted data frame here that shows you how many total cases per million you have in each country. And then we're going to use this data frame to do the same map we did before, maybe with a different scale. I prefer the Veridis color scale. And let's take a look at this. Nice. So as you can see, now you can see how you can definitely see South America is a bit in trouble. You can see Spain and France are in a bit of trouble as well. Czech Republic, and I believe this is Belgium, or no, this is, yeah, it's probably Belgium. And then you can see some of these Middle Eastern countries here are quite affected with COVID. So this is a pretty cool visualization for the world maps as well. So now let's do something else. Instead of mapping these things, and we can do maps all day. I love doing maps, by the way. You can do the top 10 countries per million on a scatter plot. Now, I'm not going to go to detail with these plot tools here, or maybe I should, but what I wanted to say is that to get a top 10, we just use this range here. This is a list range, so instead of doing it like, if you remove this, you get all the countries in the world, and it's going to clutter up this nice little plot. And so we just do the top 10 countries here, filtering it out. All right. What's pretty cool here is that these balls or circles are scaled to the kingdom of cases. So it's a nice way to get a representation of like how much Bahrain has compared to Peru. It's roughly twice the size in the ball size here. So that's pretty cool. And later on, you can do this again for total deaths. You can see this is total deaths per million, by the way. So that's why San Marino, which is a tiny place, has a lot of deaths per million. Whereas you can see now Peru, Belgium, Bolivia, Brazil, Spain, all these countries were badly hit by COVID and they had very high death rates. So this is a pretty cool visualization as well. So as I said, there are lots of visualizations you can do with this COVID data set, and I would love for you to just go and experiment and then share this with the other students in this Udemy class so they can see what other cool visualizations you have done as well. So now let's move on to the sixth section, which is the evolution of confirmed cases per million. So these are going to be maps, but these are maps with, let's take a look, timelines here. So we'll see how we do that. So stay tuned. Okay, so now let's do some very cool plots, which I previewed in the last section. These are the evolution of confirmed cases per million. So you can actually see on a timeline scale, when you press the play button in this graph, you can see how it evolves over time. And what's very cool about Plotly is that if you look at this, all you have to add differently is just animation frame equal date. Now let's go back up to see if that was even an option in the previous one, and no. But it's exactly the same thing. Sorry, not this one, my bad. This one here, you can see there was no animation function argument here in this function, the choropath function. Okay, apologize for my stuttering. I just lost my trend of thought for a second. So now you see you have it here. So you have continuous scale, hover name, you have all the same things, and all you have to do is just add an animation frame equal date, and there we go. So let's just take a look at this. Let's run this now. And these take a little while to load because I'm guessing it's doing a lot more in the back end, generating these type of animations here, but it doesn't often take that long, maybe about 20 seconds. Now, I've actually paused the recording and stopped it because I did find a bug in this, and I actually discovered the cause of the bug and then realized I can fix the bug, which is a bit frustrating. But look at this here. So firstly, I just want to show you what's cool about this. You can play this back and it looks awesome and cool just like this. You can see different countries, how they got affected, who got affected worse over time. You can see Iran and Spain had it pretty bad, UK and Germany and France as well. US as well, but US didn't get it that bad just yet, I believe. Actually, no, they were pretty bad, actually. Looked at the scale incorrectly. You can just pause it here as well and stop it here. But you can actually drag this across. And what I love about this is that the axes, the legend here, adjust as you move this. So I had a problem in using ggplot in R, for those of you who are familiar with that, and I couldn't actually adjust the scale automatically like this. I had to do some sort of tricky workaround to do it. But anyway, this actually worked quite well. However, here's where the bug happens. You can see the date here, date equal to September 24th, and we keep going until the 23rd of October, and then bam. For some reason, we start back at January 1st, 2020, where only China had it. And the reason for that is that animation frame, even though it should be looking for a date in Plotly, but it isn't. It's looking for a string, and even if you sort this, you can probably sort. Actually, I tried sorting the data frame, and it didn't work because it still looks for the date index, and it's only reading it as a string, not a datetime function. Maybe they'll fix this later on, but as of now, there probably is a way to work around it. They just haven't spent that much time trying to figure it out. But I don't quite like how this is, because now it's starting here, and then you're gonna have to play it from this side to get back to continue. So annoying bug, but we can live with it. Now here's the same thing here, but in total cases per million. Well, this was just total confirmed cases. And let's just generate this plot. Takes about 10-20 seconds to do in Google Colab. We have patience, so we'll wait. We're using a different color scheme now, Inferno, which is one of my second favorites. Verdis and Inferno are actually, we're using Inferno, the last one too, but Verdis and Inferno are quite cool. I love them. So you can see this is this is what did I say this was? Total cases per million. Yeah, sorry, cases per million. And you can see, so basically this will give you a better reflection of what's happening all over the world, because it takes in consideration population size now. So let's just leave it on the present day here. And whoops, went back into time. So this is what's happening right now. So you can see the Western Americas here in the West are affected quite badly right now. And Western Europe is getting there as well. I think France had like 40,000 cases yesterday, so it's not good. So now let's move on to the 7th section in this case study, where we compare continents and countries. So stay tuned. Alright, so now let's move on to the 7th section, where we compare countries and continents against each other. So just a reminder of what our data frame looks like. That's why I have the DF head here, just in case you forgot. And what we're going to do, you can see that actually in this data frame there's continent here. So we're just going to group by continent, new cases per million and new deaths per million, and then sort it on new cases per million here. I know it's a long chain command, but it's a very simple command anyway. We rename the columns here in the next line, and then we just change the data types country to string, just to make it look a bit cleaner, and then we get this nice little data frame here. One thing I should say is you should probably just ignore a lot of these pandas warnings right now. They aren't there's more like advisory methods on what to do in future, because some of these things may not work in future, but as of now it works, and I pretty much don't think Pandas is going to change this anytime soon, I hope. But when it does, I'll actually update the code later on, so it won't break. But for now, let's keep it like this, keep it simple, because I think these types of commands here are quite simple. And I know some of the recent Pandas updates that used a lot of things like iLock and lock and sort of change some of the stuff, make it a bit harder for beginners to understand. So anyway, this is just a grouping here per continent, so you can see how many cases. Europe has the most, followed by Asia, North America, then South America, and then Africa has the least right here. And in terms of deaths, Europe is again leading in deaths, but North America is actually second, and then third is South America, for fourth Asia, and fifth Africa. So now let's just do a simple country comparison. So let's create a data set with only the US data. So we just do the location equals the United States, and we just have this data frame here with only the United States data only. I think I said only twice there. All right, anyway, and then what we're going to do, we're just going to reload the data here because we've made some changes here, and we deleted the world previously, remember that? So let's just do a simple thing to capture the world data here. So now we have the world data frame separately. So what we're going to do now, we're going to plot these both on a graph by using add trace function here. So we have the figure equal.go. This figure is the object. We just add the trace here using go scatter. X-axis, just take the same date. It's going to be the same date on both axes anyway. The difference is going to be the Y, total cases, for the DF USA and DF world. And let's just put in the titles, nice and simple. And there we go. And you can compare any amount of countries like this. You can actually create a new data set. And in fact, let's do that right now. So let's add, how about we compare the US with, let's say, India right now? Because, you know, India has a lot of cases. It's probably second to the US, I think it is. We just saw that previously. So let's create an India data set. All right. And now let's just add in another line for India. So you can just copy and paste this here. Made a mistake here. Total cases in India. So we have it right. Should automatically change the color. There we go. So you can see US, this is the US, the world cases here. And you can see India and US in the bottom colors below. So you can add any number of countries here to this list to compare. What to do even better is actually to do it per million, and you can go compare a bunch of different countries, and you Plotly produces these very nice, elegant looking graphs that you can present and make you look all professional. So now let's compare the deaths in the US to the rest of the world. Just do one more different field. Whoops. And here we go. And again, it's the same type of graph. You can do this the exact same way with any number of fields in this data frame. There's so much you can do with this data set. I love it. The only thing it's lacking is active cases, but that's fine. We have almost everything else. So we can just mess around with a bunch of different things. So now let's move on to the very cool exercise where we basically create a Flourish bar chart race. So that's coming up in the next section. Thank you. Alright, welcome back to the lesson on how to create a very cool Flourish bar chart race. So, as I said before, you can't actually see how cool this is here. So let's take a look at the finished product in Flourish. This is what you'll be making here. So let's start this from the beginning. And you're going to make something pretty cool that actually exactly like this is what you'll be making. And I think it's pretty cool. So you can see this is actually shows you the leader of who's leading the COVID cases, or the number of COVID cases over time. This is the date right here, total count. And you can see, like, this is very cool to visualize, like to see which countries had accelerations. Like, look at India. India is just going to overtake Brazil and just ramp up here. This is as they approach close to 100,000 cases per day. And this is where it stops. We're actually going to do it till October 23rd, I believe, yeah, in our lesson. So now let's take a look at how we do that. Now, the first thing you should know, let's go back to our collab notebook, is that we have our data in this format. Can we load this data directly into Flourish? And the answer is no. Whoops, okay, I actually need to restart my notebook, so let's re-import pandas as PD, and that'll fix that issue. Now, as I said, this is not the right format that Flourish can use at all. Flourish isn't that smart. You have to give your data into a specific format, and this is our raw data set that we imported from our world in data. And you can see it's definitely not like easy for some other program to interpret. So what do we do? Let's take a look at Flourish's dataset data requirements. So that's on this tab here. And this is the layout of the Flourish dataset. You have a country in one column here with like an index number here. This isn't actually necessary, to be honest. You can delete this column, but that's beside the point. Then there's an image for the image URL. This is for the flags in the countries here. So I hope I don't confuse you, but Flourish requires you can put any image you want here. So what I thought would be cool, which Flourish actually kind of does for you partially, because Flourish does give you a lookup table for data, for the flag data URLs here, conveniently. I didn't have to populate this, okay? And then afterward, you have every date here in a column, starting from January 1st, 2nd, 3rd, and this column contains the confirmed COVID cases that we'll take from our spreadsheet. So now what you're going to be doing, you're going to be doing some simple data wrangling to take the data from this CSV file here and bring it into the format that Flourish needs to create this cool visualization. So it's quite easy. So let's take a look and see how it's done. So the first thing you'll need to do is change the date format, because you have it in 2019 12/31, and as you can see in Flourish has it as day, month, year. So we'll need to change that, and to do that, what we do, we just take this date column right here, and this column is actually an object data type in pandas right now. You can double check that if you want. Just go df.info and you will see it's an object, and what we want to do is change this object data type to a date time. So once we do that, we can use this function here, the dt string time function, and what it does, let's just do this here, is that it firstly changes this in this first line here to a recognizable date time data type for pandas, and then after we change the format here, so you can see now it's in the time we want, which is Monday. Yeah, sorry, I actually said it wrong. This one is Monday, yeah, as well. Okay, so moving on now. What else we need to do is that we need to take this data axis here and set it to the main axis here, and you'll see why. Okay, so let's just do that first. So now we have date as our index right here. Okay, so now moving on, what we need to do, we need to get the dates basically here as columns here, and then hold country country mainly, and maybe an index number on the columns here. So I hope I'm explaining that right, but what we're doing here, we're just going to pivot on this date here. All right, we have done pivots before in the earlier pandas lessons. If you want to review them before, just to make sure you understand them, it's very similar to a group by, but a little bit different. So what we can do here is we pivot the data frame here. We use values as the values we want to keep in the columns. We're pivoting on index. So index just maintains itself here, and the columns we'll be putting in the new data frame would be the date columns. All right. So, and then what we do after, we just remember there are tons of NAs in the cases numbers here. We're just going to convert those to zeros, and we get this wonderful data sheet that looks very, very similar to the Flourish data set now, doesn't it? Okay. Now what's missing? Well, flags were missing. Remember we had this image URL for the flag images. Let's go back and see how we get the flags in the plot. Now what I've done, and you can use this in any project you want, is I've created basically a CSV that contains the flags and the links for every country in the world. So let's just take a look at the full data set if you want to. 208 countries are here. We have the country names here and the flags here. So if you're using this to do like an merged data set, what I mean by merged data set is that if you want to use it to append the URLs to the relevant countries in this, what you do, you just do a simple merge or join right here using pandas. So you can just do a pd.merge. This is the dataset Flourish. This is what we're adding the flags to here. And then we're using the flag data set here. So we're merging these two. Left on, because we want to use this as the main sheet. On location, which is the country, which is what we call country in this data set here, in the df Flourish data set. And we're right on, that's what the other data set is, on the flags. So these are what we're going to merge on. So we do this, and voila. Now, well, this is exactly what we wanted, because you can see the image URL is here. Now, Flourish kind of has it here. Now, it doesn't need to be here. You could have put this image URL all the way to the end. I'm just scrolling to the end here, at the end here. However, for convenience sake, you want to have it up front, because every time you're uploading data here and you're adding it, you can just put ZZ at the end here, and that way it captures all the columns here, which you will see shortly. That you need to see that in action to understand what I mean. But let's take a look at this slowly. So now what we want to do, we want to do two things, actually three things, I should say. We want to bring image URL here to the second column right here. Squeeze it in between location and January 1st. Now, second thing, you would have noticed as well, we have an extra country column here that we don't want to keep, or we can just either move it to here or rename location country and delete this one. There's a number of things you want to do, but we don't need to have this here is what I'm saying. It's redundant. And last thing, you can see this column here, 31st of December 2019, starts at the end here, whereas it should be here. So what we'll do, we'll just delete that column back, because it actually doesn't have much data in that column. So we can effectively start it at January 1st for convenience sake. However, also you can move it, but the problem here with Flourish is that it doesn't actually, with pandas, that we didn't actually sort properly on dates. So we should have done that before, but that's okay, because we don't need to. We've got some other ways around it. So look, this is going to generate our final Flourish table from this data frame right here. So first thing we're going to do, we're going to have to save this file as a CSV so that we can import it into Flourish here. So what we'll do, we'll name our file, our CSV file in this line 21 here, will COVID cases underscore the timestamp, that's today's date, just the month year, and .csv. So that way, every time you run this code and update the file, you don't overwrite the old one, and you also know what date that file originated from. Because I was updating some of these Flourish visualizations for some groups I'm in daily, and this was quite convenient for me to do, just to keep naming the file, giving the file the timestamp of today's date. Okay, so this is out of the way, and this is out of the way. So let's take a look at these middle sections of the code. So what we're doing here, we're deleting the unnecessary columns. Like I told you, it's just two columns we want to get rid of. So we do del, del, space the data frame name and the column name we want to delete. So we wanted to delete country and these two columns here. That's December 31st, 2019 and country column. So those are deleted there. Then we wanted to actually move this image URL column all the way to the beginning here. So here's how we do that. To reorder the data frame here, we create an intermediary data frame or series right here with this column. So we're holding this column in that data frame there. Then we drop the image URL column on the main data frame we were playing with. And then what we do next is that we insert the column, the series we created here with the image URLs, back into the main Flourish, the data frame here. We insert it into position 1. This is position 0. So position 1 is currently this one. So when we insert it there, it pushes everything to the right. Whoops. And that's how it actually works. So it's quite simple. So it's create an intermediary, drop the column we want to move, and put it in where we want to. And that's it. And ta-da! Now you've got your Flourish dataset ready to import straight into Flourish. Okay? So let's go ahead and do that now in the next section. Thank you for watching. All right, welcome back. So now we're going to take our processed, cleaned up data frame that we saved as a CSV and bring it into Flourish. So this CSV that we saved here with the pandas function .toCSV, where does that file exist? Well, that file exists since we didn't specify a directory that we wanted to save the file in. It exists in the same folder that this IPython notebook file is located in. And in Google Colab, you can actually find that folder right here. You can get those files right here. So whenever you don't specify a directory, it lands up right here. If you were doing this locally, whatever your current working directory is, or basically where this file exists, is where that file would be saved. So to access this CSV file in Google Colab, just click on the left bar here, the last fourth icon, Files, and you'll see the file right here that we just created. So remember, we saved it here, We don't have to delete this twice because second time we run this, it won't find that. That's silly me. Okay, so let me just take this off for you guys so you won't have to be doing this. So anyway, the file exists right here. As soon as you highlight the file right here, you'll see these three little dots right here. Click on them and click download. So now download file here. Well, I already downloaded it before, but it'll exist right here in your downloads folder. And then what you do, you go to Flourish. Now, when you go to Flourish, it's actually going to look like this. Let's just go to Flourish. Whoops. Flourish.studio. And what I want you to do is sign up if you haven't already and create an account. And when you create an account and sign in, this is what Flourish takes you to, this little main page here. So if this is your first time using Flourish, you're not going to have any of these projects here. These are my projects that I've created for one of the groups I belong to, one of the Caribbean COVID groups. So what I would like you to do is click on New Visualization. And this brings up a whole list of templates that Flourish has created for us. They have tons of cool stuff right here. A lot of them are quite easy to use. Some of them not so easy to use, but that's beside the point. The one I want us to make is one of the very cool popular ones in Flourish, probably their most popular visualization, which is the bar chart race. So as soon as you see bar chart race here under the bar chart race tab in this page, this section, click on it, and that creates a blank canvas for you to use. However, this blank canvas actually has some data on it, as you can see here. So this data, when you click on the data tab here, you can click on preview and data to alternate between these two windows in Flourish. This data has some data for, what data is this? I'm not even sure what data it actually is, but it's some data for every country in the world. And the main purpose of having this blank data is so that people can actually see how or what type of data or how the data is supposed to look and be pre-formatted or formatted before you upload into Flourish. So you can do this in Excel, you can do this in Sheets, or you can do it in Numbers. We're using Pandas, which is the cooler thing to do because you have a lot more control. So what we need to do now is import or upload our CSV file. So you can see the files right here. So I'm just going to upload this one and upload import publicly. So one thing you should know is when you're using a free account in Flourish, all of your data you upload is public. So if you want to stop that, if for some reason you have sensitive data, you can go private and pay their small fee. I'm not sure what it is, but I know it's not too exorbitant to get their private and upgraded accounts. So for now, let's import publicly here. So you can see this, when it says 172 rows were imported, this means it was successful. Now they have something saying next, select the columns. That's this area here. So let's do that. So as you can see here, this is our data that we created in Pandas and Google Colab. So this is pretty cool. You can see all the cases here as they go up. So it's awesome to have it. So now what we need to do is just check our columns to make sure. Now label is the most important thing here. Well, the second most important thing, the data is actually the most important thing. But label, if you look at the preview right now, you can see it looks sort of like this, kind of messy. Actually, it has some of the features I actually changed before, but your default project isn't going to have this. So what we need to do is change label to B. B means we want it to be the label of the country code here. Next, just this column values. You don't have to change anything because Flourish imports it correctly. That's this purple column here. This basically tells Flourish where to look for all your data here. So it tells you to look from D to all the way to the end, ZZ. ZZ just basically says any data to the right, even though we don't have a ZZ column. We're not nearly as far. We're on K, I believe. Yeah, but ZZ just tells you anything to the right will be considered data in the CSV file. Categories, we don't have categories, so let's remove that as right now as blank. And for images, we're just going to use the image column, which is the image URL right here. So that's it. So now let's go back to preview, and you can see it doesn't look as fancy as maybe it did earlier in my one. So let's see what we have to do now. So firstly, I like to have a little more countries than this, so I can put it at 20 and see it automatically changes the top 20 countries right here. Now, the next thing we need to do is, you'll notice something a little bit annoying in Flourish is that as soon as it reaches the end of the data, it restarts. And if you're like me, you want to see basically the most recent snapshot in time of this bar chart race and pause and maybe reflect on it. Now I know you can pause here, but because the dates are moving so fast, it's hard to pause precisely on the last day. So what you do, you go to timeline and animation and you tick off loop timeline. This means as soon as it reaches here, it stops. And it prompts the user will now have to press this button here to restart the animation. So I think that's pretty cool. Now you can see all of the columns are one color blue, and it's not even a nice shade of blue, it's kind of like a pale blue. If you want to change it to have every country as a different color, you change the color mode from category to by bar. Category allowed us to categorize, have an extra column here and categorize it differently. Like if we wanted to actually categorize it by continent, which would have been cool to do, we could have added that there and then filter by, and then do the column mode by category to have like an extra layer of information in this graph. But it's okay, we don't need to do that, it's fine. You can do it on your own as a side project if you want to just improve this visualization for yourself. Next, what we're going to do, we're going to actually just add in sort control. I believe sort control is here. So giving the user some more coverage, some more ability to control. So you can see the bottom countries as well as the top countries. Could be cool to sometimes see. Next, we're just going to put a header. The header will be a title for this. So let's just put World COVID-19 confirmed cases. And let's see. Don't need to put a subtitle. That's it. So it comes up and it's a nice font and everything. You can center it if you wanted to. Just leave it centered for now. And then what else can you do to make it cooler? I believe that's all the major things you can do. You can actually play around with these settings. You can change various like bar sizes, styles, all of these things. Now if you wanted to do annotations as well, you can put these into. So I encourage you to experiment because Flourish has a lot of cool customizable features as well. So now what do? How do we share this cool visualization with our friends? You just go to this top right area here, export and publish, and it says not yet published. So let's publish to share and embed. We don't want to have a password, we want everyone to see it. So just click publish, and there we go. It's published now. So how do we actually see this publish? Well, how do we share this? You can do two things. You can copy this link here to basically share it on your website, or you can copy this URL right here by clicking this and, well, sorry, just copy and paste there. So you just copy it. And there we go. So you now have this, when you give someone this link, you can share this directly on Facebook or email, and you have this very cool Flourish visualization that you're free to share to the world and make your own ones. This COVID data set has so many cool things that you can create. So go knock yourself out and have some fun. You can actually, what I would encourage you to do is do one for your region. Like I did one for the Caribbean region, and it was pretty cool. You can do one for if you live in Europe, if you live in the subcontinent in Asia, or wherever, Africa or South America. Just do one for those countries there, and you can share it with your friends on Facebook. Everyone is going to ask you, oh my god, this is so cool, how did you do this? And you can just point them to my course. I can give you some, like a what do you call that, affiliation fee. Okay, so maybe I can do that with you guys if you share my course. All right, so that's it for this lesson. Thanks a lot for viewing, and if you have any questions on Flourish visualizations, let me know. Okay, so thanks a lot, guys. Bye.
Subscribe now and press the bell icon. Never miss an update.